Myself. Good, thank you. I'm glad you came back. I would nevertheless like to continue that theme after welcoming you and read another quote from Carl Sagan, who did that television series called Cosmos that was so important some years ago. And I think it's quite prophetic, and it sets the theme for what I would like our distinguished panel to talk about later this afternoon when this is through. So let me just read this to you. Sagan said, "Science is more than a body of knowledge. It's a way of thinking. I have a foreboding of an America in my children's or grandchildren's time," and I think this applies globally, but this is about the United States, "when the United States is a service and information economy, when nearly all the key manufacturing industries have slipped away to other countries, when awesome technological powers are in the hands of a very few, and no one representing the public interest can even grasp the issues, when the public, the people, have lost the ability to set their own agendas or knowledgeably question those in authority, when, clutching our crystals and nervously consulting our horoscopes, our critical faculties in decline, unable to distinguish between what feels good and what's true, we slide almost without noticing back into superstition and darkness." Now, that's not a very slightly gloomy prospect, but I think a lot of that has come to pass and needs to be dealt with. As I said to you this morning, at the Science Network, we embrace this challenge. We support science in its search for solutions. And I think it's important to remember the other statement of Sagan's, that the vision of science is a candle in the dark. So this panel, I hope, will be suggesting some candles in the dark, some solutions from their own perspectives, their own particular areas of expertise. The order will be that Richard Somerville will start, distinguished professor from Scripps Institution of Oceanography and an expert in the physics of clouds. And he will set the scene with a slideshow. We will then go to Jean-Michel Cousteau, who will make some remarks and then show a DVD, which he will talk over. Patricia Ricard will have a movie or a DVD also. And the minister will have no visual effects, but will be stunning in his own right. So let us begin with Richard Somerville.
I'm the scientist of the four of us, and my task is to set the scientific background for the topic that we're going to discuss. I've been a coordinating lead author for the Intergovernmental Panel on Climate Change, the organization that shared the Nobel Peace Prize a year ago, and that produced a report that is the definitive summary for the state of the science of climate change. I'm going to show you a few figures from this enormous report. And then I'll say a few words about policy and solutions, which the IPCC cannot do because it is required to be neutral on subjects of policy. This is the beginning of the science story about climate change. This is the record of carbon dioxide rising in the atmosphere. It's a record due to one man, Charles David Keeling. I'll say a word about him at the end. But there's no doubt about these data. People can disagree about many things, but they can't disagree about facts, and this is fact. And it's a fact today that more than 1 out of 4 molecules of carbon dioxide in the atmosphere is there because we humans put it there. This little cartoon from the IPCC report summarizes the remarkable progress in modeling the climate using computer simulations. The figure starts at the top left, and you can see that at the beginning, computer models were very simple. Carbon dioxide was in the simulation. There was a simple water cycle. And then reading from left to right and going down the figure, you can see things being added. Clouds at the top right, a simple ocean, a swamp at the middle left that didn't move, that just provided water and heat. And then in the last three panels, a real ocean, a simulation that came closer to the effects of the ocean on the climate system. The ocean dominates much of the climate system. It's a reservoir of heat and carbon dioxide and ignorance. And in the last figures, you can see that the ocean now is able to simulate many regional aspects, such as the Gulf Stream circulation. And at the same time, computers have become more powerful. The language here is code for the IPCC reports. FAR, First Assessment Report in 1990, SAR, 1995, the second, 2001, the TAR, the third assessment report, and the fourth one, the one at the bottom last year. And you can see here that at the beginning, the Mediterranean was 7 little blocks in the computer simulation. The Alps were 2 blocks. As computers have become more powerful, the ability to simulate regional aspects of the climate system and smaller details that are very important to climate and to ecosystems and to people has improved greatly. So at the same time as the climate has been changing, the science has advanced extraordinarily fast. This is a major figure from the IPCC report showing how all 6 inhabited continents have warmed. That's the top 6 figures. The black line is the observed record of rising temperature. At the bottom left is the global average, and then the land in bottom center. And the ocean on the right has been warming too. The pink and the blue are computer simulations. Only the pink simulations simulate the warming recorded in the last 40 years or so. The blue ones don't. The difference between the pink and the blue ones is that the blue ones are natural factors only, the sun, volcanoes, but the pink ones include the man-made gases that add to the greenhouse effect, like carbon dioxide, and the effect of particles, air pollution. And so we have here one long line of evidence, one of many, that shows convincingly that the observed warming in recent decades is very likely, better than 9 out of 10 chances of being true, to have been due primarily to human agencies, mainly the effect of human beings in adding to the natural greenhouse effect. The ocean affects the climate system in many ways. As I said, it contains 80% of the heat that's been added to the system. We know that all the major ocean basins are warming to depths of 3,000 meters. Sea level is rising, and one of the things the IPCC decided it could not predict, the science isn't yet far enough advanced, is the possibility of rapid rise in sea level in coming decades because of the possibility of destabilizing ice sheets such as those on Greenland. You can see that kind of thing happening in this picture here. Melting water from the surface flows through crevasses called moulins down to the place where the ice sheet is grounded on bedrock and can lubricate the ice and cause large chunks of it to fall into the sea. Today, both melting ice on land and thermal expansion of water in the ocean are contributing significantly to sea level rise, which is accelerating. This is a hurricane. It was Hurricane Katrina in 2005 that devastated parts of the United States. And the color code here is that the ocean is coded by temperature. The yellows and reds are the warmest parts of the ocean. Hurricanes are creatures of the tropical oceans. They occur in the warmest parts of the ocean, and they occur during the warmest parts of the year. And there are good reasons to think that in a warming climate, the strongest hurricanes will become more strong. And in fact, that's happening in the Atlantic in the last 30 or 40 years to a statistically significant effect. Both hurricanes and the possibility of destabilizing ice and causing rapid rises in sea level are areas of research where the science hasn't all been done, where there are still questions to be answered. The IPCC distinguishes very carefully where settled science has happened because the research frontier has moved on and left settled science in its wake. Our report says so. Where things aren't known yet, there's still questions to be asked and answered. There's still research underway. We say that as well.